So, hello everyone. So we are the water pollution team. So we have myself, Divyanshi, Anam, and Geta from Africa, Ethiopia. He's joining from there, and Anam and Divyanshi from India, and I'm from UK, working on a project on to Bangladesh. So to begin with the water, so
Wait, honey, sorry. We can
yeah,
only see your slide on half the screen, so it's very small for us.
Is there a way to do
just a
full
moment.
screen?
I'll just share
Just,
it again, maybe.
yeah, share it as a full screen. That's the easiest way.
Yes. Is it now visible?
No, it's doing the same thing again.
It's like upper right corner.
Oh, yeah, it's our issue.
Oh, okay.
Standard. No?
Oh,
Uh,
because
maybe it is. Maybe it's not.
yeah,
Yeah. Um,
when you share your screen, can you see just your the presentation? Because we also see your face
okay,
on
go
half
back
the.
to the. So somehow it's showing
Okay.
your camera as well. Are
Okay.
you
So
just sharing
Divyanji, can you
manually at the
share?
screen?
All right,
Yes,
I'll
I'll
Yeah, why
do
don't we
share.
that.
have another person share?
I'll share it.
And
Just give me one
Just a
moment.
moment and check on that.
it's
Is
working
it
now. It's
okay?
working.
Great.
Yeah.
Perfect.
Yeah.
Yes.
Okay. Okay. So we started with our by the numbers. So the by the numbers context was to understand that what is the severity of water pollution in India. And with the by the numbers estimation, I used some of the estimation that how much industrial water and how much the household water has been treated. We saw that recent case that happened in Indore, where the water was equally polluted, was highly polluted with E. coli, and that leads to a lot of fatalities as well. So the estimated number came around 1.6 million cases per year of probably of severely death cases that happened below 5 years of infant because of polluted water and because of severe diseases like diarrhea. That's the major cause behind the death of infants in under 5. So with the Fred Park, we aimed to understand that can we build scalable and cost-effective testing diagnosis tools. We started with the understanding and of how do we scale the diagnosis and how do we build something which is cost-effective, which is portable, which could be done on fields, and which could be done by unskilled or layman person and citizens that they could use to understand the pollutants in their water. And building upon the Fred Park, and we try to understand that what are the different scenarios in Bangladesh, from India, and from Ethiopia. So we have Geta from Ethiopia. Geta, if you would like to say something upon the Fred Park that you built.
Okay, thank you.
Yeah.
I'm Geta Masai Nuguse from Ethiopia, and my by the number which is state about facts in Ethiopia is more of I am interested to the capital city of Ethiopia, which is Addis Ababa. So as I can see from the number, I can see the disparity between demand and supply, and it assumed like in 2037, it's assumed the population will be 9.8, and it require 1.1 million cubic per day, but we are currently having half of that, and so leaving 47% deficit. And also, we have a problem of distribution loss among the water channel system, and so we are only providing, the city is providing around 38 or 40 liter per day, but which is below the standard of 100 liter per and also new dam where is under construction, but this only address like the uh, uh, 6.6 of the future demo. Reservoir much most of the two big
I believe, yeah.
supply.
So
So
Yeah.
One of the issue is strategy and
Gita, your
use
voice
of
is cutting a
water
little bit.
from.
Yes, so I believe, Keta, your voice is cutting a little bit due to maybe internet connection. So I will proceed with some of the measures that Keta also provided from his part. So we understand that there is a huge pollutant issues that is in Ethiopia as and simultaneously in Bangladesh and simultaneously in India. So we collected some samples. So we saw the arsenic was not that much of concern in Ethiopia. However, we saw some of the cadmium was a little bit high, and we saw that some of other like chromium was also a major pollutant, lead was also a major pollutant from the Ethiopia sample, and simultaneously from Bangladesh. We collected sample from Chaudanga, and we understand that it was 60 times higher than the WHO limit and 12 times higher than the Bangladesh standard, which shows a serious concern in the drinking water in Bangladesh. And similarly, we collected a recent study that, according to that, they actually highlighted the arsenic contamination and the sources of these contamination that is happening in Bangladesh because of the climate change. The huge clean drinking water of Bangladesh frequently get contaminated by high saline water, and that is also one thing which actually limits a lot of drinking water for the Bangladesh population. And simultaneously, we understand that the impact of water pollution on public health is really high in Bangladesh with respect to waterborne diseases, organ damage and dysfunction, skin diseases, cardiovascular diseases, and cancer rates and infant mortality. So these are all the parameters that has been taken by recent research studies that have highlighted the grievance of of polluted drinking water in Bangladesh. And one of the other study, the consensus of this Fred Park and the consensus for this idea was that if we create informed awareness and if we create scalable diagnostic tools that are mostly used by audience, that will increase the information and awareness, and that also increase the public health institution to provide the accessibility to clean drinking water. And exactly the study by Asgar et al. 2025 actually simulated this by using AI, by using the agentic ecosystem for societies. And they did it on the private well users in Ireland and showed that by combining three water testing with communication campaigns, significantly increased participation in safe water practices and influence policy design. So, on this consensus, we wanted to establish the understanding of how we can build a scalable diagnostic tool. So, these are some of the metrics that were taken from the WHO standards that are allowed in clean drinking water. And we saw many instances where cases from India that they have been surpassed in a significant way. So this is the map which shows the high arsenic, the cases of arsenic geographical distribution from India, and the kind of regions that we're seeing are mostly increasing in these contamination. So arsenic testing, then we concentrated our aim for arsenic because we saw that there are different categories of pollutant in drinking water. So we wanted to concentrate on one identification of one pollutant significantly, and arsenic was one of the prominent that was common in Bangladesh and that was common in India with high concentration. And we understand that arsenic testing is based, a lot of colorimetric arsenic testing is based upon the Gutzit method, which is the standard method which is used to detect arsenic. And we understand that the present available methods or field kits that are using Gutzit method, they are highly they have hazardous call, so they are very restricted to travel, and to actually the accessibility is really less. You need laboratory infrastructures, they are costly, they are apart from that they required skilled technicians to handle the test and to interpret the test. And up from this, I believe Divyanshi will take over and she will explain the further aspects of arsenic testing that we identified in our Fred Park. So yeah, Divyanshi, please take over.
Thank you so much, Anna. Can we move on to the next slide?
Yeah.
All right. So, when we talk about arsenic testing, there are two major categories. One of them, which Hani already talked about, is colorimetric test, where we use certain reagents which produce a colored compound, and on the basis of the intensity of the color, we determine the concentration of arsenic present in water. Other than that, we have sophisticated laboratory methods which are very good, which are very sensitive, as well as offer high precision. But the problem is they are very expensive. Also, we can see that as study of 2026 point out that arsenic in water is present in two major forms. One of them is in trivalent and the other one is in pentavalent form. So the pentavalent form is more stable form. And that is why it becomes even more difficult to detect arsenic in water. Next slide. So this heat map shows the global expanse of arsenic pollution in water. As we can clearly see, a lot of underdeveloped and developing countries are facing arsenic contamination in water, and that is why it becomes a major concern to address as well as to find a solution which can easily detect arsenic in water. So earlier we had colorimetric sensors, which basically detect arsenic through color change. But the past decade shows that there have been a lot of advancements. For example, now we have nanomaterial-based sensors, microfluidic devices, biosensors, and electrochemical sensors. It clearly shows that research community is also interested in designing and developing various methods which can detect arsenic with high precision. We can move on to the next slide. This method is electrochemical sensors. So these methods offer very good precision when we talk about arsenic testing. But if we think about it, it's very difficult to deploy in remote areas or in the field. And we need experts to perform this test. Next slide. Then we have biosensors, which deploy certain nanomaterials. We can show the table. We can move on to the next slide. This table shows, this is a holistic table which talks about various biosensors which have deployed various nanomaterials to detect arsenic. We can clearly see a lot of them have a really broad range. They can detect very small amount of arsenic in water as well, but all of them come with their own challenges. So understanding various types of tests like electrochemical sensors through biosensors, we have come up with major themes. When we talk about advantages, almost all of these sensors are very specific. They have broad range of detection, and a few of them are cost effective as well as portable. But the major disadvantage was the sensitivity issue. So they are very sensitive, which means they are easily affected by pH level and other environmental factors. And it's very obvious that the water quality of, let's say, India will not be like that of Bangladesh. So sensitivity was a major challenge. Another difficulty, which almost all the tests have, was it is very difficult to reproduce them in remote settings. And to reproduce them, we need experts. It cannot be done by a normal person, a normal layman person. Yeah. Additionally, research papers talk about the fact that we need to integrate artificial intelligence as well as Internet of Things to enhance as well as to increase the precision when we talk about arsenic monitoring. So, next slide. So what we found is we are having some major challenges of sensitivity, specificity, reproducibility, and hence our research objective is to overcome these challenges and to also integrate technologies like Internet of Things and artificial intelligence to enhance detection, to enhance precise detection. So the major questions we arrived at after discussing a lot among ourselves is, do we actually have a scalable diagnostic method when we talk about arsenic testing, which can also be calibrated according to the regional environment, according to the topography? Next question which we had was, are the sensor-based diagnostic methods really scalable when we talk about arsenic testing, or we need to move on to better diagnostic or some other diagnostic methods? And the last question was, can we collect enough data for training a machine learning model which can enhance our predictive analysis? Because when we need to train a machine learning model, we either need data in form of image or table. So these are the three questions which we are discussing, and we are still brainstorming.
So because our FRET
Okay,
part hours, yes, please. So the floor is
I was
open
going to
for the
say,
questions. So
okay,
because
perfect.
our
Can
FRET
you
part
go back to
initially, yeah,
a slide
I was
back?
saying something.
Sorry, go ahead.
Yes. So
Yeah.
because we started with the understanding that building a diagnostic tool would be we needed to build a cost-effective diagnostic tool, but the problem actually itself isn't diagnostic, it is not specified. So we came up, it was like discussing a problem where we identified another problem, which it's something that we are still upon. So because we need a chemical expertise and to understand this particular scenario. So that was the idea. The idea was to build a AI based technology and an app that could scan the result and could identify that is the arsenic level is present or high, and which could be scalable to among the citizens so that they can use easily. So yeah, that's it.
Yeah. So a quick comment. I think the most insightful thing that I got was this idea that when we design many of these tests, there are so many of them, we design it for a single parameter. You take it to the
Yeah.
field and it doesn't work because, of course, the water doesn't just have this one thing, it has a large number of unknowns. And so kind of, you have to reshift and go backward that you want multi-parameter tests to then
Yeah.
infer back. So I think we're solving the wrong problem in some sense, because at the end of the day, if a sensor is designed for one specific thing, but all
Yeah.
your data is dependent on correlated other things, while you know that natural water will have an unknown number of things, there's a mismatch between. So, for example, for pH, could you say for the Gutsid test, how sensitive is it to pH? Is there, because I could imagine taking the readout that you get, but also have a pH measurement and then use machine learning to recalibrate of what it would have been for. Like imagine a very large scale multi-parameter data set that's collected, and
Yeah.
then you are able to correlate and calibrate things in the field. So is there an intuition for thinking about just for that one parameter, the comment you guys made about pH? How sensitive is it to pH? Or how have people talked about the failure modes, common failure modes for some of these common tests, for example? I mean, voltammetry is incredible in terms of thinking about how sensitive it is. There is a couple of groups I know that have made low cost probes for electrochemical testing, so that I know that field, and in the end, it's a signature that you could learn a lot of things on. But
Yeah.
where are there enough studies to show how these things fail?
Yes, so there are not enough studies to exactly understand the failures. So, for example, the environmental parameters like pH and salinity in the water, how it affects the field testing kits, and what are the false positives that these tests may indicate, and how are these calibrated? Because one example I could give is that we were able to procure a arsenic test kit in UK, and we were able to actually ship it to Bangladesh to make it more feasible for the NGO. And when we did that, we consulted with the NGOs and we tried to brainstorm that this particular kit will work. And the suggestion was that most of these field kits they have already tried, and most of them does not work on their data and samples that they take because they are not calibrated. So the kits that are made for UK tap water testing for arsenic levels will not work at Bangladesh well water or maybe surface water, because each water category will have different parameters, as you suggested that there are multiple variants. So yes, this is something which we aim to work upon, and I aim to dig more about how this could proceed. So
And then
yes.
the test that you guys shipped to Bangladesh, is that the Dutsit strip? That's the one that we had found online, or it's a
No,
different
no,
test?
that's a different test. It was
I
available
see.
by a Simple Health. It's a I think the organization is registered in UK, and they provide for UK tap water testing. They provide
Yeah, one of the
portable
problems with the
kits.
Dutsit test is it's almost 100-year-old, but it uses a lot of corrosive agents. So you can't give it to somebody and let them test. Okay, any other questions?
Yes.
Yes.
So I have two kind of, I guess, ideas on the like multi-parametric point. So one of them is, have you guys looked into these dyes called polydiacetylenes?
They're like these
Okay.
like colorimetric. They like change color in certain patterns, and like you can play with like the lengths of the tails and like the functional groups at the end of the tails, so that you can kind of get like different types of responses, and you can get like more specificity. So that's one
Yeah.
idea. And the another one, I think this might have been mentioned, but like you can apply like different waveforms to the water and like see how the response like this is kind of how it comes back. And then you can just like kind of vary that a ton. And that also might be able to get you a little bit of specificity.
Yeah, I
Okay.
think the comment there is rather than searching for one thing, look at very high degree of freedom measurement tools. Raman is one
Okay.
example where it's sensitive to everything and tiny bit of signatures change, but no human can read a Raman signature and say what the values are. But that's where training can come about. I mean, I think electrochemical tests sort of go in that same direction as well. Uh,
Yes.
so
Yes.
rather than thinking of chemistry that's specific to one specific chemical, these are just generally sensitive, and then we decipher and solve the inverse problem mathematically. There was a question at the back. Yeah, Kevin.
You mentioned a few times that some of these tests require expert knowledge. Like,
Yeah.
is it just because the chemicals are corrosive and dangerous, or is there an operational aspect that you can tackle? Because part of being frugal and accessible to the masses is that it can be operated by a lot. So I'm just unsure.
Yeah.
What expert
What's the
knowledge?
degree of
So with
expertise for covering
Yeah, so
testing?
for the traditional gutset test that are based on arsenic gas detection, it is hazardous. So it is clearly specified on the test kits that it should be done under a laboratory setup. So that would not be something done by a general audience. And apart from that, the readability and understanding of these test results are also challenges if you want to scale it for rural audience in Bangladesh. Then how clearly the test, because most of these tests require some level of understanding of these reagents that are used and how to use them, particularly when the testing is done. So these are the two challenges that the NGO that are working in Bangladesh also faces, because they have to, so they have accessibility to laboratory there, so they have to collect the sample, they have to collect and then send them back. Even they are not able to do the field test themselves. So that is something which, because of the hazardous materials that these kits have. So yes,
Yeah, it's a
that is
strange thing.
something
If
that
you're
we need to.
producing arsenic gas as a test output, you take something less hazardous, you make it even more hazardous to detect it. It's kind of is going backwards. Are there any other questions? We're going to do one more presentation, so I want to make sure that we get time for it. So we can squeeze in another talk. I mean, I think one comment I wanted to make, which I had not appreciated, the link between climate change, sea level rise, and pollution or sort of contamination of your freshwater sources. Because when I think about
Yes,
Bangladesh, I see these massive floods, and those floods would give rise to brackish water entering freshwater areas.
yes,
I think that's what you
yes,
were highlighting, which I had never
yes,
equated two together in that particular way. Because I can then imagine that once that source is contaminated, okay, the flood goes away. Now what? You have brackish water in your freshwater resources, nothing you can do about it. And so I don't know what the
yes.
recovery process is.
There
And
is no recovery process yet. So they have a lot of ponds and they have a lot of small lakes that are in Bangladesh that are majorly the area is when the flood comes and they get polluted and when it goes back. So these small sources of water also get contaminated and they
yeah,
become unfeasible for drinking. So
yeah,
presently, it's something, the geographical location of Bangladesh is also a biggest challenge because they suffer from the downstream position of every
yeah.
river. If we see that the rivers go downstream in the Bangladesh, so most of them of these rivers are already polluted that they come across, and then with the flooding, it becomes the problem becomes worse.
And what is the original source of the heavy metals at fertilizers?
I think it's in the
Yes,
soil.
Yes,
So
yes. Either
is it
fertilizers
only
and
fertilizers, or is it also in native? It's naturally present also. Like why
no,
these
it's
particular regions?
the agriculture, pesticides and fertilizers,
Okay.
and then the heavy dye industry and the
Yeah,
industrial waste is
clothes,
also the clothing industry is really
clothing that
heavily
we wear.
located in
Yeah.
Bangladesh. So because of the majority of the clothing industry is in Bangladesh, so that is also the source of these highly heavy
Mhm.
metals in water.
Yeah, because most colors utilize heavy metals to get the
Yes,
foaming
yes,
effect.
yes,
Yeah,
yes.
yeah. Okay, we're gonna switch. Let's do one more
Thank you.
talk. I'm hoping some people can stay. I know we're gonna bleed a little bit.